And there it is, 7:02. Okay, good morning, everyone. We should be able to get through this in about 42 seconds and get you all back to work making money again. Ha, I'm such a jokester. Welcome to another Gensco Quick Hitter, provided to you by the Gensco DSG Group, Diamond Service Group members, who are basically Mitsubishi tech support for all you guys. Today we're going to discuss Mitsubishi M&P defrost cycles, how they work, and what can go wrong. So here we go. And the main thing that you guys should be aware of is that all of this information, most of it anyway, is available on my link drive under App Notes, Application Note 1041. 95% of what you're going to see came straight out of this application note. And we're going to start off on one-to-one systems M series, covering basically the gauntlet of what you have out there right now. And you're going to find a commonality between all of these units and how the defrost cycles work, mainly that it is temperature initiated, provided that a defrost time delay has expired. And the other commonality you're going to see is that that time delay is not a fixed number. It's a moving target and based on several factors. Starting in M-series one-to-ones, the starting conditions of a defrost, or if the outdoor defrost thermistor is reading a certain number, and it ranges from 26.2 up to 34 degrees. And the defrost timer has passed its limit, which is again variable from 40 to 150 minutes. 150 minutes being 2.5 hours. The variety of that time delay depends on defrost cycles themselves. If we have a short defrost cycle, we're going to add time to the interval. And if we have really long defrost cycles, we're going to take time off that interval. In this manner, Mitsubishi is trying to be as efficient as they possibly can and not defrost unless absolutely necessary. Got a lot more people coming in here. Okay, shoot, we're up to 41 people. Awesome. And more than 5 minutes has passed. These are the starting conditions of any defrost cycle in these units, meeting the defrost sensor requirement and the time delay having expired. During the defrost, the reversing valve would de-energize, meaning every one of these units, reversing valve energizes in the heat mode. The indoor fan is going to stop, so we're not blowing cold air because we will now be in air conditioning mode. The fan may keep running at a very low speed if you're using a wireless handheld, the controller that comes with the unit out of the box. The outdoor fan will stop. The compressor frequency will go to high speed to try to move as much mass of refrigerant through the outdoor coil as possible so that we can actually defrost it. And the defrost condition or operation will cease when any of the following conditions are satisfied. We have reached the defrost finish temperature for at least 30 seconds. Now, the defrost finish temperature also varies between different units. Defrost time has exceeded 10 minutes, or the indoor unit has been placed into any other mode except heat. That is basically how a one-to-one system defrosts. And an SUZ one-to-one system Defrost thermistor reads 26.6 degrees Fahrenheit or less, and the defrost timer, which is the same, 40 to 150 minutes has elapsed. And more than 5 minutes have passed since the start of the compressor. So it could have been cycling on and off, satisfying set point. The defrost timer keeps going. And the compressor has run at least 5 minutes on the next startup where the defrost timer has expired. Again, the interval will extend or shorten 0 to 20 minutes depending on the previous defrost interval. The reversing valve again is de-energized in the SUZ. This is basically the same features as the MUZ. The stopping conditions of the defrost when we have reached the defrost finish temperature for 30 seconds. Defrost time exceeds 10 minutes or any other mode has selected on the controller inside other than heat. Now, what can go wrong with these units that would not defrost? Faulty temp sensors, obviously. If we are reading a temperature on the defrost sensor that is way higher than the initiation temperature, we're not going to defrost. Or the temp sensor is not actually on the piping, which is in the multi-zone, so you will see, is the most common cause of those units not defrosting. You could have a faulty control board. You could have a faulty coil on the reversing valve, or you have a lack of sufficient refrigerant charge. Again, it takes a mass of refrigerant flowing through the coil, which contains energy. And if we have only, say, 1 pound of refrigerant in the system, we don't have as much energy available as having 4 or 5 pounds in the system. That may cause it not to defrost completely. Usually when you see that, you're going to see a thick layer of ice toward the bottom of the coil, never defrosts fully. And the picture you see here is indicative of a unit that's not defrosting. On the hyperheat unit, there is no, and by the way, how do you initiate a defrost cycle on any of these particular units? There's no defrost initiation switch. The only way that you can initiate a defrost cycle, if you're trying to see one, is to block the outdoor coil, typically with a large plastic bag, and wait for the cycle. Now, you don't know where the timer is. You could have done a defrost 55 minutes before you showed up on the job site, and you're waiting 2.5 hours. If the unit has a power cycle, wherever the defrost timer is, it will reset back to its minimum. So in that way, blocking the coil, power cycling the unit, waiting 40 minutes, you should see a defrost cycle. Again, in these 1-to-1 units, MUZ or SUZ, even the hyperheat up to 18,000, it's the only way to see a defrost cycle on these units, other than just standing around and waiting. Now the SUZ hyperheat 24 to 36. I'm only going to describe this unit and not so much P-series units because these units are actually the same as a P-series unit. So while there are subtle differences across the range of P-series model numbers, I'd need another entire quick hitter just to talk about P-series differences. But they're very similar and close enough that if we go through this, you're going to see basically the same thing in a P-series. So what gets a defrost started in an SUZ 24 through 36 hyperheat? TH3 temp sensor needs to be 28.4 or less for 7 minutes after the compressor integration operation time fulfills. That's the prohibition time or the interval between defrost cycles. In heat operation and the liquid pipe temp needs to be 23 degrees or less if outdoor air temp minus 18 degrees or less after compressor integrating operation times fulfills defrost prohibition time. And I got a bunch of numbers in here, T1, T3, and you're going to see a chart. And again, all this is in this app note. You can go back to my link drive when this is over, review it, print it out, spread it around the office, have a little training session yourself. This presentation is being recorded and will eventually end up on Gensco customer website that you can view again later. Or condition C, heat operation and the outdoor temp continues to be 28.4 or less for 7 minutes after reaching our prohibition time. T1, and the compressor stops twice within 10 minutes from its startup. Or condition D, in heat operation, outdoor liquid pipe temp continues to be 23 degrees for 7 minutes after the compressor fulfilled its prohibition time. And the compressor stops twice within 10 minutes from its startup. This is what initiates a defrost in this unit, and most P-series units operate the same way. Now, A refers to defrosting operation with a light frost amount on your coil. B indicates defrosting with heavy frosting on the coil. C indicates the defrosting in case the temperature adjustment is turned on and off frequently, being on the inside of the house, and the frost amount is small and the condition load is heavy. That is so confusing. The D indicates defrosting operation in case the temperature adjustment is turned off frequently because the frost amount is large and the air conditioning load is light. Operation at the beginning of defrost. The indoor fan stops. We don't want to blow cold air on anyone. It may keep running at a very low speed if you're only using a handheld controller to control the unit. If you're using a thermostat to control an indoor unit, the fan will stop. The following options or events will take place if one of these conditions in section 1 is detected. Compressor operating frequency decreases to 30 hertz, frequency of spinning. When the compressor operation frequency reaches 30 hertz, four-way valve is turned off, the outdoor fan stops, the LEV pulse is set to wide open. After A and B are completed, the compressor is set to a fixed operational frequency of 74 hertz. That's spinning frequency. Stopping conditions of the defrost. 15 minutes have passed since the operation started. You might see 15 minutes when you're low on charge. The outdoor pipe temperature thermistor has reached 68 degrees or more within 2 minutes. Or the outdoor pipe temperature thermistor has reached 50 degrees after more than defrosting operation has conducted for 2 minutes. During defrost operation, the compressor has been stopped due to errors, or you turn the unit off, or you change mode inside. At the end of defrosting, the indoor fan resumes normal operation. The outdoor fan starts. The compressor frequency is decreased to 30 hertz. The compressor will stop for 1 minute when the compressor reaches the 30 hertz before the reversing valve switches over. Then the compressor will return to normal operating frequency. And that chart where we talked about T1 and T3s, I've cleaned this up from the actual app notes, a little fuzzy, but the defrost prohibition time can be anywhere from 150 down to 20 minutes if TH7 is less than 15 degrees C, negative 15 degrees C. TH7 is equal to or less than 15 degrees C, the defrost prohibition time will lower. Or T3, TH7 is less than negative 15, TH7 negative or equal to 15 C, and the time can be 3 minutes, 2 to 7 minutes, 2 to 10 minutes, 2 to 15 minutes, or 15 minutes. Defrost prohibition time will begin to shorten the longer the defrost cycles. The shorter the cycle, the greater the defrost prohibition time. That is basically what this chart is referring to. In the 30 and 36, same numbers for defrost time. but the minutes are slightly different. We go to a higher up to 180 minutes, which is 3 hours if our defrost cycles are extremely short. Defrost cycles are extremely long. We begin to shorten that up until we have very little time between defrost cycles. So this is common across all systems, whether they're M or P. The shorter the defrost duration, the longer the time in between. The longer the defrost duration, the shorter the time in between. Prohibition time, previous operation time T1. If the operation mode changed to a mode other than heat during defrost, 70 minutes. Protection devices worked during defrost operation, 10 minutes. Initial prohibition time when power is reset, 70 minutes. So what can go wrong with these? Well, the same thing that can go wrong in every unit. You could have a temp sensor faulty. You could have a faulty control board, lack of refrigerant charge, or faulty reversing valve coil, or stuck reversing valve. You can initiate a defrost cycle on these units. SW1-1 on the outdoor unit from off to on will start a defrost cycle, provided the compressor has operated for 10 minutes and the pipe temperature is less or equal to 46 degrees. So if this temperature outside, say, is 50, 55 degrees, you're probably not going to get a manual defrost. You would have to block the coil in order to get the temp sensor down below 46 degrees. But you can initiate defrost on these units because enough P-series units or the SUZ 24 through 36 hyperheat, I see a typo up there, by turning on SW1-1. And again, the SUZ 24 through 36 is basically the same thing as a P-series hyperheat, and all other P-series units have very similar operation numbers, some variances, and again, I would spend another hour just talking about P-series, but they all follow the same patterns. So if you review the SUZ hyperheat defrost conditions, operation, and termination, you're going to be in the ballpark on the P-series. And all P-series can, using SW1-1, can initiate a manual defrost. Now, multi-zone units. Starting conditions. Defrost thermistor reached 27.9 or less Fahrenheit. At least 30 to 150 minutes have passed since the last cycle. 45 minutes after a power cycle. So if you reset power to the unit, the defrost interval is set to 45 minutes, blocking the coil. You could initiate a defrost cycle. The minimum interval increases and decreases by 0 to 20 minutes, depending on the length of the previous cycle. More than 5 minutes have passed since the startup of the compressor. During defrost, the reversing valve will be energized. In C-series multi-zone units, the ported version, they energize the reversing valve in cool mode. So in a defrost cycle, the reversing valve will be energized, not de-energized. The exception is any MXZ 2C20, hyperheat or non-hyperheat. Those units still energize the reversing valve in heat mode. The indoor fan will stop unless you're using a handheld remote controller. The outdoor fan will stop. The compressor frequency will go to high speed. The stopping conditions of defrost, if the defrost thermistor reads 55.2 or more, and the defrost time has exceeded 10 minutes, or any other mode has been set on the controller inside. So you see a pattern between these units that they pretty much follow the same programming. Now, ported multi-zone units. Similar conditions. Defrost thermistor reads 26 or 2.2 or less. At least 30 to 150 minutes have passed. 5 minutes since the startup of the compressor. The defrost thermistor reads 29.3 or less. Ambient temperature of the defrost thermistor equal to or greater than 12 degrees. When conditions A and C are satisfied, the interval is 30 to 150 minutes. 150 minutes for the first time since power up. And when the conditions B or E are satisfied, defrost interval is 30 to 150 minutes. 50 minutes from the first time since power up. So depending on your actual temperature sensor reading, your interval on a power up is going to be pretty long or it's going to be shorter. So be careful if you're trying to initiate a defrost cycle in one of these units and you are warmer outside, that interval is going to be longer on a power cycle. During defrost, reversing valve is de-energized. These valves energize in heat mode. The indoor fan will stop, or if you're using a handheld controller, it may run at whisper speed. The outdoor fan stops. The compressor frequency goes to high speed. And to stop defrost, defrost thermistor reads 55.2 or more. Defrosting time has exceeded 10 minutes, or you change the unit out of heat mode. What can go wrong? Faulty temp sensor. And in the MXZ multi-zone ported units, the most common cause of a defrost issue is that the defrost thermistor has been pushed out of its holder at the bottom of the coil. When I have defrost issues on these units doing a tech support session, this is true about 80% of the time. The sensor has been pushed out and it's just hanging in the bottom of the unit. You could have a faulty control board, faulty coil on the reversing valve, stuck reversing valve, or lack of sufficient refrigerant charge. There is no defrost initiation switch on ported multi-zone units. Same as on a one-to-one system, you will block the outdoor coil with a large bag and wait for a cycle. And again, be careful if it's warm outside. Doing a power cycle could reset the timer back to a longer interval, and you could be waiting a while. Where if it's really cold outside, the defrost time will be shorter. Interval will be shorter. Branch box units during heating operation will intermittently enter defrost mode whenever it detects frost on the heat exchanger. This is from a different app note for MXZ operation, branch box unit operation. It's not in the app notes that was described in all the other units. We have had 15 minutes of defrost operation, or after all defrost conditions have been satisfied, it will go back to heat mode. Defrost operation will start when either of the following conditions has been met. TH3 reads less than or equal to 28 degrees for 7 minutes, and the compressor has been operating for at least 20 minutes. Light frost. Defrost operation will stop when any of the following conditions has been met. The system has been in defrost for 15 minutes. TH3 reaches 68 degrees within the first 2 minutes, or it reaches 46 degrees after 2 minutes of defrost operation. Now, TH3 sensor measures the temperature of the liquid pipe at the outdoor unit. The LEV will open to 60 pulses on units that have already met set point. And defrost operation cannot be canceled by any controller command. The indoor unit controllers will display standby while the unit is in defrost operation. So unlike the other units, you cannot take this unit out of defrost mode simply by changing it at the thermostat. You won't be able to. They will be locked out and in standby mode. The indoor vane position goes to the cooling position, horizontal. Reversing valve is turned off, fan motor off, indoor fan off. This is on branch box type systems. What can go wrong? Faulty temp sensor, not actually being on the piping. Control board, reversing valve coil, lack of sufficient charge. One of the things in branch box units, if you guys have done them, you will notice that they have rather large accumulators. And it is not uncommon. A few more people joined late, sorry. It is not uncommon to have a unit that is short cycling, to end up stacking all of its refrigerant in the accumulator. Thus, the unit operates like it's low on charge. So be careful of this. When you have a branch box type system and an application where it is short cycling, either it's extremely oversized or it's not a primary residence and the set point is very low for freeze protection purposes, which causes the unit to short cycle. And I'll show you a picture and a description of a job in a minute that actually had that happening. You can initiate a defrost cycle in these units by turning on SW7 switch number 6. The compressor must have been in heating operation, compressor running for at least 10 minutes. And you can repeat this. If you have a unit that's pretty frosted up and you're trying to get it to defrost, you could do this defrost sequence every 10 minutes of compressor operation until you get the coil defrosted. Now, this is a unit that had serious defrosting issues, a branch box system with 2 air handlers inside the space, and the set point using smart set was set to 50 degrees. It short cycled extremely badly. And on initial troubleshooting of this unit, it was thought to be extremely low of refrigerant. I watched it cycle through 2 defrost cycles, and the picture you see on the right is the extent of the defrosting. It would not defrost this unit. It would build up ice so badly that it actually broke the fan blade off of one of the fans. Thinking that this thing was out of gas, we pulled the charge. It required us to repeatedly run hot water over the accumulator to get all the charge out of this unit, but we recovered the calculated charge, 22 pounds and 5 ounces. When prior to recovering it, I was surprised if we were going to pull 3 pounds out of this unit. And again, this was due to short cycling. So if you run into a branch box system that is having defrost cycle issues, there is a way to check for starts on the compressor and hours of operation and determine if it is short cycling. Or investigate the job conditions, like in this case, the set point was extremely low. It leads to short cycling. One of the things, if you're troubleshooting defrost cycles, to look out for, short cycling. And with that, does anyone have any questions?
I know you said most of this comes from the app notes, but is there much spoken about this in the service manuals?
Sometimes.
Okay.
Not every time. There was a very old tech manual for M&P units that's disappeared. It's very old and refers to units 10 plus years older that had a lot of good information in it, but so much has changed in those 10 years, they have not reproduced that book. Jason. I think the app note is pretty detailed. I was worried about putting all this in here actually because it's kind of dry and, you know, hard to relate to people. Most techs should read that thing 2 or 3 times to understand some of the terminology and the sequences, especially those P series numbers. why I did not include all the P series stuff in here, because it's extensive and it's got little subtle varieties between different models that make it hard to grasp. What makes defrost noises so loud or louder than others? Well, anytime we have excessive noises, first thing I want to know is, do we have the right charge in the unit? That could be one reason. Or we could have mechanical issues in the compressor, louder than others. Can I send you the slide deck, Desiree, if you can, let me type my email in here. I will be glad to do that. This is no secrets here. So if you email me at the email address I just added, I will be happy to send you this presentation and a copy of the app note. SUZ KA24 attached to, I assume that's an SVZ KP24. Follows the, it's not a hyperheat, so it would follow the standard M series protocol or heat pump. Let's see what else I got here. Can short cycles and low indoor temperatures cause icing? Well, it can cause the icing to build, sure. If you have a low set point, 62 degrees, you're going to short cycle more than you normally would. And the unit takes that into account. If we're satisfying the set point often, that's a lot more time before we actually get a defrost. We're going to keep extending that defrost intervention or interval time. What temps become too cold for units to keep up with defrost? Well, it depends on the unit, but anyone who's done this for a long time knows there's like a magic window between 25 and 35 that is ideal for building frost. If we get really, really cold outside, we actually don't have enough physical water in the air to cause as much of a defrost issue or buildup of frost that we do when, say, it's 30 degrees outside. So going, say, 15 to 30, you would expect to see probably less frost at 15 than you would at 30. And if it's a hyperheat, well, we should be good down to negative 13. Does it build up on the accumulator? Ice. Yeah. You remember, in heat mode, your evaporator coil is outside. It's going to be below freezing most of the time. So ice will build up on all the piping from the coil to the accumulator, sometimes to the compressor. But it's not unusual to see the accumulator extremely iced up. Yeah, if you live over in the Kittitas Valley, where it's 15 degrees and foggy, expect to have a lot more defrost issues. Thermostat interface on 1-to-1 units. Thank you, Doug. Thermostat interface where you're using something like a Nest, especially the older version of the thermostat interface. There's a newer version out now, the 445. The 444, the unit did not construe a thermal off condition where we satisfied set point as a thermal off condition. It considered it a you turned me off condition, and it would reset the timer back to 0. We thought we had issues with units when we would find these units looking like an igloo, but it was using the interface and short cycling. 1-to-1 units especially, because They might be right. My defrost timer might be 150 minutes, and I've been running for 140, and the thermostat's satisfied. Went back to 0. Multi-zone units, same thing applied, but the more heads you have on a multi-zone unit, the less chance that you're going to actually satisfy all of them. So it wasn't as much of an issue. On the new thermostat interface, there is a dip switch setting to extend the time that the unit is considered to be on 2 hours, which to my knowledge so far, I have not run into any units using that interface one-to-one that have had defrost problems. But if you have a PAC US 445, or sorry, 444 out there on a job, you would have probably found it already, defrost issues. But if you have one that's been chronically having defrost issues, that could be the case. Not the case with MHK2. That is a constant communicating control. Any Mitsubishi controller constantly communicates to the unit what's going on and what its conditions are. It's only when you use that interface that there's an impossible for the outdoor unit to know what the thermostat's actually doing. It's guessing at those numbers. Well, how could you confirm it's a bad circuit board? One, you're going to have to try to initiate a defrost cycle and wait for the time delay if it's one that does not have a defrost initiation switch. And then see, is it de-energizing or not de-energizing the reversing valve, depending on the unit. If it's a ported C-series unit, remember those energize in cool. The other units energize in heat, except for the 2 C20 series of ported multi-zones, which energize in heat mode. Sensors are good, charge is good, RV coil is good. How do you then test a bad board? Just as I described, try to initiate a defrost cycle. Even at the maximum of 150 minutes, if it never initiates the defrost cycle and the sensors are good, and are they good? This is where I would, or we in tech support would probably suggest, if you don't have one, to get one of the M&P maintenance tools and look at what the system is seeing for a temp sensor. You can sometimes measure temp sensors with your meter and they appear to be good, but the unit is not interpreting them correctly. So while the sensor may measure good, if you look at it with the maintenance tool, it might say, oh man, I'm off 50, 60 degrees here. What's wrong? Are there indoor conditions or settings by the user that can cause a defrost cycle more often? I don't know that he can cause a defrost cycle more often. He can certainly cause it to happen less by having his set point really low, as described earlier. Good question. Is it the sensor or the board that's causing the reading to be off? It could be either, unfortunately. When you're measuring a temp sensor using your meter, you're typically putting 3 volts to that temp sensor, where the board is putting 12 volts to that temp sensor. So especially if you have a nick or something in the wire where it's bleeding off voltage to ground, say, you might not pick that up with your meter. But when it's plugged into the unit, it could. So you could start with the cheapest thing, changing the temp sensor. That doesn't solve the problem, then it must be the board. Remember, if you're having issues and you're going to contact technical support for some assistance, please have your model and serial number ready before you call. There's a lot of information we can ascertain from just having that, which would help us before we called you, be ready for whatever your issue is. So good question, Mike. What does the dip switch do for defrost and high humidity? In the branch box type units, there is a dip switch for high humidity conditions. You're going to shorten that interval. You're going to increase the actual defrost cycle time. If you're having defrost issues on a particular unit, by all means, contact Jinsco Tech support. Some of the units have a way to increase the defrost termination temperature. It's going to require cutting something off of the board. But before you do that, please contact us so that we know we're doing the right thing. Yeah, take a picture of the data tag. Brian, thank you. And I would add to that, take a picture from an angle that it can actually be read, especially the serial number. We get a lot of like 10,000-foot views of data tags. Can't read a damn thing in that. The maintenance tool does work well with M&P series units, John. If you have never used it before, on Gensco Customer is a recorded quick hitter from 2 summers ago on how to use that maintenance tool. And you can also get help with, again, Gensco Tech support. Anthony, you might want to do that again if you're living in Kittitas Valley, somewhere where you have cold temperatures and you have extremely high humidity, fog, for instance. That place is crazy over there. And it's a case-by-case thing if you're not in the Kittitas Valley. And what may be an issue today may not be an issue the rest of the year. So it just depends on our little microclimates that we have all around Puget Sound. I've seen this be an issue for someone in the Sammamish area who lived right on a lake. And you would get days where fog would develop over the lake, and they lived right next to it. That had to be set to increase defrost frequency. You also want to be careful about air distribution coming out of the outdoor unit, that it's not being recycled back into the unit due to some blockage someone put in front of the unit, because that can increase defrost cycles. A different maintenance tool, but the same software, does provide information about branch box systems in much more detail than it does on M&P systems. M&P systems have limited detail, or I should say M-series systems. P-series systems have more detail available than M-series units, but branch box units have a wealth of information available using the maintenance tool. And if you guys don't know how to use the maintenance tool and you want to learn, I also suggest that you download from I'm going to type it in here. TeamViewer.com, free personal use for quick support. You don't have to even know how to use your computer, as long as you can turn it on and connect it to Wi-Fi. Through a program called TeamViewer, us in tech support can help you with your computer stuff, or learning how to use the maintenance tool, and we can explain what we're looking at and how to interpret the data.